All right, so just going to show you just a basic mathematical concept of exponents, which I'm pretty sure a lot of you have dealt with before. So really quick, just dealing with exponents. All right, and we all know the exponent as that superscript number up in the top right corner of the number. So for example, I have, let's say, 2 squared or 2 to the second power. Again, this is your exponent, okay? And here is your superscript. That's what it's, for my English people. So here you go, superscript. And your 2 right here would be considered the base, or base number, as some might say. All right, so we've seen this before in some kind of calculation. So hopefully this should help you out with a little bit of homework that you may be doing. And also I'll give you a small example of how you can actually use this in your daily life. All right, so here, let's say if we do have that 2 squared, the exponent simply tells us how many times to multiply the base number to itself. So in this case, since we have the 2 here, it's telling me to multiply the base number of 2 to itself twice. All right, so I'm doing 2 times 2, which in this case is 4. Just like if you had 2 cubed or 2 to the third power, you simply do 2 times 2 times 2, which gives you 8. All right, and so on and so forth. So you already know if it was 2 to the fourth power, you have 2 times 2 times 2 times 2, and that should give you 16, so on and so forth like that. All right, so that's basically what the exponent does. It just simply multiplies the base number, or tells us how many times to multiply the base number or base to itself. All right, here's just some simple rules that goes with that. All right, first off is your product rule. All right, so you have the product rule. Okay, the product rule simply says, and this is assuming that you have the same base. Okay, this is assuming you have the same base. As a matter of fact, all the rules we go through, majority of them will have the same base, and this is how this works. All right, so let's assume that you had a base number of a, 1 to the power of m, 1 to the power of n. The product rule simply says we just take the 2 exponents and add them to each other. All right, assuming the base number, are the same. So let's assume that we had 2, let's say 2 squared for one times 2 squared, 2 cubed for the other, right? Let's assume that. So we're really saying 2, all right, 2 squared plus that, which should give us 5, right? So we should have 2 to the 5th power, 2 to the 5th power, which should give us, I believe, 32. All right, so let's assume if you multiply them out separately. So we know that 2 squared is 4 times 2 cubed, which is 8. So what's 4 times 8? 32. So that's the reason why that works like that. So just to let you know, again, you have to have the same base number for that to work. So I'll show you when you have 2 different bases, how that would go. It really is a simple calculation. All right, and let's kind of look at that now. As a matter of fact, let's say if you did have, let's say, a to the n times b to the n, right? Well, we can't say, okay, a, b, and then n plus n. We can't do that. No, because I'm pretty sure some would take it as that. No, we can't do that. Simply a times n, a to the power of n, all right, times b to the power of n, and that's simply what it is. A, n, b, n, like that. It's nothing you can do with that except for just multiply them out. All right, oh, and here's another rule, because I know some people get this confused. I'm going to do this now. So let's say if I went back, I'm going to use that same rule of 2 to the second power, or actually 2 cubed. Okay, now some would think that I'm saying, 2 times 3, which is 6. Again, this is not correct. All right, so when you have the power, it's telling the base number, again, how many times to multiply the base number to itself, all right? So you're not multiplying the base number to the exponent. The exponent is simply telling us how many times we multiply the base number to itself, all right? Just wanted to clarify that. All right, moving on. So that's the product rule, okay? Now, next would be the quotient rule. So you have the quotient rule, okay? Again, this is assuming you have the same base. So if you have the quotient rule, let's assume you had a to the m power at the top and a to the n at the bottom. You're simply doing this. Now you go from the product rule, which is addition, to the quotient rule, which is subtraction. All right, so you now have a to the power of m minus n. All right, so another good way you could look at this, and let's assume you had, like, I don't know, let's say if you had 3 to the 4th power over 3 squared. Now, we could use this and say, okay, 3 to the 4th minus 2, as we know, is 3 squared. Now, for some, if you feel like you have to expand it, and I would suggest doing so if you can't see it, here's another good way you could look at it. Notice how I'm crossing certain numbers out. Sorry about that, 2. I meant to write 3. All right. So 3's, like 2 3's, or 4 of the 3's cancel out. How many 3's are left? So I simply have these 2 3's right here, right? So we just simply take that as 3 times 3, or 3 squared, as we know as 9. All right. So again, that's another way to see how the quotient rule would work. So again, we are assuming that we have the same base number. All right. So we cannot have different base numbers for this to work. We have to have the same base number. All right. Okay. That was the quotient rule. All right. Next is the power of power. Power of power. What is that? Power of power. Sorry, I can't even write today. Power of power rule. Well, what is that? Well, it's simply this. Whatever the base is, to whatever the power is, and you have a power on the outside, you're simply taking that and multiplying that power on the outside to the power on the inside. So in other words, I have the power of m on the inside with the power of n on the outside. And I'm just going to simply multiply the n to the m, or the m to the n, however you look at it. All right. So you take that, and let's assume you did have this really quickly. I'm going to just say 2 squared times 2, right? So either way it goes, I should have, was that 2 times 2, which is 2 to the 4th power, as we know is 16, right? So let's say if I multiply this out, what's 2 squared? 4. What's 4 squared? 4 times 4, which is 16. There you go. So with the power of the power, all right, again, you're just simply multiplying the exponent from the outside to the exponent on the inside. All right, that is the power of power rule. All right, next one, really quick, is the power of a product. Power of a product rule. All right, power of a product rule, okay? And this is how this one goes, okay? So in this case, let's assume that you had 2 different base numbers. All right, so now let's say if you had 2 different bases, okay? And you had some power on the outside, all right? So you have a times b to the power of m. You can simply take the m, this m right here, all right, this m right here, and just simply attach it to both base numbers on the inside. So in other words, you have a to the m, b to the m. All right. And that's really all you're doing for that. That's really all you're doing for that. So I would challenge you to actually put some numbers with it just to see how it works. All right. So that way it give you a little bit of practice. I don't want to take all the fun from you by just simply, putting the numbers in for you. So I'm allow you to do that. But that's simply all you have to do for power of a product. All right, that's all it is to it. All right, and now you have the, let's say, power of the quotient. Power, can't write, power of a quotient. All right, power of a quotient rule. Okay, let's assume you had A over B. All right, let's assume you had that. A over B, and let's say if it was to, I'm going to use the same power, M. All right, so again, just like the power of the power of the product, and like we just attached the M to all those base numbers inside the parentheses, the same thing applies here. We have A to the power of M and B to the power of M as well. And that's really how you deal with that. All right, all you're doing, again, you're just applying the exponent to the base numbers on the inside, and then you go about your day. All right, and that's the power of a product. All right, I'm going to show you a couple more, which I'm pretty sure that maybe you were waiting on, and maybe not, I don't know. But just to kind of give it to you anyway, this is what these are. All right, so your negative exponents. Negative exponents. Negative exponents. Okay? Well, what does a negative exponent do? Let's say a to the power of negative n. All right? Let's say if you had that. So a to the power of negative n simply tells me to take the reciprocal of that base number. And I'm going to simply make that negative exponent positive. That's all I have to do. All I'm doing is doing the reciprocal. All right, I'm doing the reciprocal of that. All right, so or some, you just simply flip it. All right, for some of you, I'm pretty sure you like that term better. It's simply flip it. Just flip it. All right, so again, I'm going to take the reciprocal of that base number, simply just flipping it. All right, and this also, I'm going to show you how this also applies to the quotient rule as well. All right, you just simply take it and flip it. That's all that you do. All right, so again, let's assume if you had the same thing. All right, I'm going to use negative n this time. Of course, you can use, as a matter of fact, let's do the same thing. Let's say if I had negative m. All right, let's say if I had negative m. All right, I'm simply going to do this. You could either write it like this, well, as a matter of fact, I'll go step by step. So again, what you're doing is you can write it like that. You could do it, kind of like applied to both. And then you just simply take like we say we do the reciprocal, or we just flip them. We're going to take this number, put it up here, and then we're going to take this number, this a, and bring it down here. So all you're going to do is write it as b to the power of m over a to the power of m. And of course, anytime you deal with negative exponents, and you do the reciprocal, you are making the exponents positive. All right, I'm going to say that one more time. Anytime you're dealing with a negative exponent, okay, and you create the reciprocal, you are making that negative exponent positive, okay? So just like here, the quotient rule, we just took it and flipped them. That's all we did. The exponents then become positive, and of course your numerators and denominators just simply flip. That's all they do, but you want to make sure that your exponents are positive. All right, so that's all you're doing is just simply flipping them. Okay, all right, so there are your negative exponents. All right, last but not least is your zero exponent. All right, zero exponent. Okay, let's say if I had a to the power of 0. Okay, the first answer I would get from some looking at this is simply 0. That's what some say. And of course, there's the argument as to say, well, why isn't it 0? Or, well, why can't we make it 0? Well, here's where I actually speak against it. And this is a rule I think a lot of us tend to forget. And this is the reason why it becomes 1, not 0. Now, think about it. When it comes to the numbers in any real number system, okay, in the real number system, we talking about pi, we talking about e, 1, 2, negative numbers, any rationals, and of course, any whole number is rational. I don't know if I explained that, but any whole number is rational. All right. So in that, each number has a common factor of 1. All right. Each number has a common factor of 1. So for example, let's say if I had 2 squared. All right. Naturally, we don't write the 1 here. We don't write it here. We don't write it. It's actually understood as being there. All right. It's actually understood as being there. So we really don't need to write it. However, 1 is a factor of any number that comes across. So when it comes to this, we say, well, 1 times 2 times 2. Of course, we know what that number is. 2 cubed, same thing. 1 times 2 times 2 times 2. Again, the 1 is not written in there. It's understood as being written in there. All right. And even to 2 to the 1 power, or just simply 2, we really write it as 2 or 1 times 2. But again, let's go back to the definition of the exponent. The exponent tells me how many times to multiply the base number to itself, right? And again, the factor of 1 is understood as being there, okay? So if we had 2 to the 0 power, the 0 is saying, well, there aren't any 2's to multiply to itself. So we just don't write it there. But the 1 is present. So that's the reason, or one of the reasons, why anytime we do the base number to the power of 0 or any number to the power of 0, it becomes 1. So I could have 1 million, doesn't matter, 0.275, whatever the case is, to the power of 0. To the power of 0. No matter what it is, it's going to go to 1. Doesn't matter what the number is. It could be 1 million, it could be 1 zillion, it could be 1 trillion, 1 gazillion, however number you want to call it. It's all going to go to the product of 1. All right. So hopefully that kind of clears up the reason why it becomes 1. Always know that any number that you come across, it's always going to have a common factor of 1, no matter what the number is. Even if it's a fraction, the fraction has the common factor of 1. So in other words, even if I do 1/2 to the power of 0, it still goes to 1, no matter what it is. Any decimal, any negative number, it doesn't matter. 1 is always going to be there. All right. So keep that in mind. But that is your 0 exponent. That is your 0 exponent. All right. So just real quick, one small application of it. And we'll actually look at this in another video, is when it comes to your finances. Okay, and like I said, we'll get into this in another video. I'm not going to get real deep into it. So this is what you call your compound interest formula. Okay, which is simply this formula here. All right, it's simply this. And notice the product up here as your power. So this value right here is the number of times, write it out better than that. Number of times compounded. All right. And of course, the T here is time, which is usually in years. All right. So when you multiply those are what you call your periods. All right. Those are your periods. So when it comes to a paycheck, it's a pay period, or whatever, if you're paying your credit card or whatever the case is, those which would be your period. So what I mean by number of times compounded, so that means like, is it once a year, which is annually, twice a year, which is, semi-annually, so that's every 6 months, 4 times a year, which is quarterly, so on and so forth like that. And like I said, I'll do another more in-depth video on just that alone. All right. But here is one application of your exponent. So if you have a savings account All right. If you have a savings account or any account that's bearing interest when it comes to money, this is what's happening. So you're actually compounding money on top of money based on your interest rate. All right. And here is your interest rate. All right. Whatever it is. Okay. But like I said, I will go deeper into it in another video. All right. But that's just one simple application to what the exponent actually does. And also I'll give you another one where, and I'm pretty sure you've done this before as well, is to actually see how much money you could actually have within 30 days if you simply double your money each day. All right, but again, I'll save that for another video. All right, but here you go. Just a simple refresher for exponents. All right, and if this is your first time at looking at exponents, here you go. All right. Please feel free to write any comments you have, good or bad, doesn't matter. Anything, of course, it should be constructive criticism, of course. But like I said, good or bad comments, I accept them all. Any other videos you want to see, please put your comments down below, and I'll make sure to accommodate your mathematical needs that way. And also, if you haven't subscribed, subscribe down below. Prof. Freddie Ratliff, that's my name. So I'm a professor at UDC. And I'm pretty sure some of you may have seen me if you're in the DC area. All right. So on that note, study, practice, and we'll try this again on a different topic. All right. Be good.